house I got from my uncle. So there's I have that. Then I made myself a little scrapyard.
Oh, really?
With a couple of with quite a few pieces of metal and a couple of weights that I had.
I don't have any layouts or anything like that. I mean, my dad does all that. I'm only interested in it because my dad's interested in it. So I kind of get sucked in a little bit.
And then there's and then I have, this came from a old homemade conference set, but I basically used the tunnel from that.
Did you you still have my book?
I think I might have left it at home.
Yeah, that's okay. You should read those stories. They're interesting. Bill, you want to do this? Yeah. What was that video you posted today? That was my advice.
I'll take a picture of it so I can show you in just a minute.
Not spray my seat. You want extra saturation? On the desk, but not the seat. That's not even my desk. On the seat. That's not even my desk. Not even the desk. Just the seat. Just the seat. Is your desk? Yeah, it's just on the desk, please. That's good.
Probably only sprinting. Then it's stopping. And it's sprinting. Yeah, that's from Costco, isn't it? How do you know? I almost got one. Really? Yeah. They're pretty cheap too. Yeah, nice.
Wood.
No.
Just switch off. Someone else. Yeah, you have the quiz, and then we can then the test. No.
But
Everyone is like, what?
I think you can do that.
I swear we just sprayed my seat and not my desk.
No. Yeah, I did 3 questions in advisory. You know what? 35 minutes is so long at school, but then when I have 35 minutes left leave for work, it's like 2 seconds. Yeah. And you know what? I really don't. I don't get that. People like those 2 points. I say just keep it 2 points. And your life will feel so long. Yeah. Nothing compares to like a minute in chemistry. Or physics.
But it doesn't feel like that.
It's so longer. No, chemistry is longer. Yeah, we don't do it. Yeah. So I can at least like pretend I'm somewhere else. I remember sophomore year chemistry was like period. And it would feel so like it would feel like 2 hours in there. And I'd be like, oh my god. It's not as bad this year, but last year it was so long. I'm imagining it's still feels long. Because I look at the clock, I would have imagined like 7 things, and I look at it.
I've never heard of it. Only bad thing about it
I'll be right back.
Why not? Do you need to go to the restroom too? Go ahead. You have to go to the restroom? You have to go to the restroom?
No, not today. Yeah, I didn't know.
Let's everybody, let's all go to the bathroom.
Really touched that.
Adele, did you have an accident over there?
I got Ross was really good. I did that just so we wouldn't do the season. We did the season.
We're live right now. No one's watching.
Oh.
No.
Is it, how do you?
We had to post a video of our advisory doing macaroni. There might have been donuts involved, so. So, hey, how's it going, everybody? Friday? We tested on Monday, which I'm really excited about. I just was working on it during first period. Yeah, so do you have questions? Do you have any complaints? Compliments?
You're idiot.
My biology teacher in high school used to do that every test. He'd say questions, gripes, complaints, compliments, corrections, or changes. He would say that every test. You're like, when he's done well. Nothing? You guys got nothing? No one has any questions? We're just ready for the test? I mean, I'm ready for it. I feel pretty confident. I think I'd get most of them right. Most of them.
Oh, it seems like.
Wait, so is it like confirmed it's gonna be 10 problems?
It's going to be 9, choose 8.
Okay.
And it's going to be 9, choose 8. And then there's going to be 2 improper intervals at the end, which I guess you could theoretically, if they're all worth the same, it doesn't matter which ones you choose. But the improper intervals are actually, I think, pretty easy. So the improper intervals don't involve any real difficulty in derivatives. Yeah, so I will tell you that, like, so we've learned U subs, we've learned integration by parts, we've learned trig subs, we've learned partial fractions. Those are the 4, right? Well, you're not going to get out of having to know all 4 because there's 2 of each. And there's enough so that there's 2 of each. So you can't, if you decide not to do one, you're still going to get tested over that. Does that make sense? Like, you can't just be like, well, I'm just going to not do any trig subs. Well, you're going to miss an entire problem. Yeah.
Does it tell you which one?
Absolutely not.
You just have to look at it and know what to do.
Like, I mean, that would be JV. If I said, oh, do this with a trig sub. Why don't I just tell you what trig sub to make? Like, oh, do this with x equals.
Yeah, that'd be great.
3 sine theta. So then, after this test on Monday, we're gonna do some applications of integration. And I will say that students traditionally find the next thing that we do the easiest thing that we do all year. So, you have that to look forward to. And then after we finish that, we'll do those applications. We'll do a little micro unit on differential equations, which I would love. I would absolutely love if we can get that micro unit of differential equations done before the end of the third quarter. That's traditionally where I like to be. And then we start the last big unit, which is infinite series, and that's basically what we do fourth quarter. I don't have confidence yet that we're going to make it to that goal. Because I think we have 2 weeks next week, right? Or I mean, after, starting next week, we have 2 weeks before spring break. And then I don't know if we have 2 weeks or 1 week after we come back from spring break before the end of the first quarter, or third quarter. I haven't looked at the calendar yet. Yeah.
How many weeks is fourth quarter then for seniors? I know that we're gonna have to keep coming back to this class, but
Like 2?
that's.
No way.
I don't know. I mean, it's crazy short. I don't know. Yeah, I really feel bad that you're gonna have to keep going back to this class, but there's no way. Plus, it's now looking like we're gonna have air testing. Like not for you guys, we're not gonna have air testing, but if you know how the schedule traditionally works during air testing, like people who aren't air testing don't come to school those days. Like that means I'm gonna be losing a whole bunch of other days potentially with you. So I gotta think through that fourth quarter, what that's gonna look like. Yeah.
If they're air testing, can you just have us come in anyway to save some time?
Well, I don't know. I'm not sure that I'll, that would be my preference, but I'm not sure if I'm going to be allowed to do that because I might have to give air tests. So, but I'm gonna just take it one day at a time. I mean, I've got some time before I have to really worry about that a whole lot. Air testing wouldn't be until mid-April, so I have a little bit of time. But yeah, I mean, air testing is that's 4 or 5 days where you wouldn't have school. And then not school on Wednesdays. I mean, I think school's just optional anymore. It's just, go. They'll figure it out. But so you have questions for me? I mean, I don't want to study for you. I don't want to rob you of the experience of studying. But did you do any review problems? Get stuck? Want some help? This is, You are right. You are absolutely right. For a few years, when we first started doing the Wright State course, I just kept using that book. And then, because Wright State's book, the one they were using at the time when we started, cost about $150. And I was like, we don't need to buy that book. Well, then I found out Wright State switched their book to this online free book. So I was like, well, I guess I kind of have to use that book if they're going to teach their class. But I do miss that book. I miss you being able to, because I would give you that. The kids had access to all the answers all the time. I think that's a really powerful thing to have if you use it appropriately. And then this book sucks as far as having answers, because even the answers that you have access to, half the time they're not right, and then you don't even have the worked out answer. It's just an answer. So. If we would have started off the school year in person, I probably would have given you all a copy of that. But I wasn't going to do that this year. And when we came back, at that point, it was like, Now you got a question? No? No one has any questions? We're just ready? Ready to like attack this? No. What do I do? I was expecting you to have questions. No one has any. That makes me scared. Should I be scared by that?
You know, like the hardest part for me, at least.
Sure, I don't know.
Well, the hardest part for
I
me
mean, we
was
can have sharing time. and we don't-
It's seeing a question and then it's seeing a question and knowing what to do. That's by far the hardest part.
Yeah, that's 80% of it, really. I mean,
Once I know what to do, I'm fine. It's seeing the question and knowing what
and so how do you get over that? Like, how do you get through that? Like,
to practice.
right. I mean, it's really practicing. It's like recognizing patterns over that only you can recognize. Like, I can't recognize those for you. Like, you have, I mean, I could say, oh, yeah, when you have this, you're going to do this. But, like, then you're all of a sudden having to memorize so much stuff that, like, you just kind of just go crazy. Whereas if you've had those experiences and those patterns and the things that you recognize, it's you own it. You know what I mean? But there are some things that I'm trying to shut that. There are some things that you can like know, oh, this is an integration by parts problem.
Yeah.
Like, how do you know when you see an integration by parts problem? Like, what are some things that are always integration by parts?
There's two different functions being multiplied.
Two different functions being multiplied together, but I think you can even get stronger than that. Like, give me two specific functions, like two types of functions that always are integration by parts. A sine and an e, right? Like if you have this, if you got this guy right here, e to the x and a sine of x, like if you have an exponential and a trig together, integration by parts, right? And now it could be e to the 2x and sine of 3x. I mean, it could be that. Now, if you've done a lot of these, and like e to the x sine of x, you will know what's going to happen with that problem. If you've done these like enough, you should be able to tell me what happens with that problem. What happens in this problem right here? Right, the original pops back up. So then you have to solve for it. Okay. What's another integration like classic like textbook integration by parts?
Something times the natural log of x.
Something times the natural log of x. You mean like a polynomial, like x squared?
Yeah.
Yeah, another classic integration by parts problem. And this one is sort of backwards in how we traditionally think about what's u. Because in this one, what's u in that? The natural log. Natural logs make great u's, right? But not every time you see a natural log does it mean, oh, this is an integration by parts problem. Like, you sort of need to check, well, is it a u sub? Because there are some problems, like, that have a natural log in it, like this. That's not an integration by parts problem. How do you do that one? That's a u sub. And you see that because you know the u sub, like you've done enough of these that you've sort of had the experience where it's like, oh, that's the same thing as this, and that is the derivative of that. Right? So some of your initial thought when you said, oh, I get this, and the hardest part for me is I don't know what to do. Some of it is like literally just calming yourself down and saying, okay, Like, I know this. Like, it's like you freak yourself out, right? There's another classic integration by parts that you guys didn't say, but I was thinking when Ross gave me that last one. It would have been like anything with like a power and an exponential, or a power and a trig. I mean, these are classic integration by parts. These two right here, you could even do with the Rapido method, right? And you could even do the other one with the Rapido, but I'm just not as big much of a fan. Like, if I have to move things around, I like it. What about partial fractions? Like, how do you recognize when you have to do partial fractions? Well, first of all, I think you have a fraction, right? Like, if you're looking at a fraction, that's a first step. So, like, let's say you have something where you have a fraction involved, like 2x plus 2 over x squared minus 5x plus 6. I'm sure you came up with that right. Yeah. So now you're looking at that. Let's run through sort of a checklist. Could you do a U sub there? Like, if you did a U sub, you would probably be thinking about U being the denominator, but the derivative of the denominator is not the numerator. Okay? We never did any integration by parts with fractions like that, so we wouldn't do that. Could you do a trig sub? Why not? Ellie, why do you say why not? You shook your head immediately, no. Well, you're thinking of...
It's like not in the formation.
Right, it's not in that form that you wanted it in for the trig sum. Like, you don't see like x squared plus something squared. Okay? So I guess the next step would be partial fractions. But what's the problem with partial fractions is we like to have the denominator factor. So factor the denominator. What happens? What happens if you factor that denominator? So what do you get, Megan? You just knew the answer to my question, like. Forgot dx. So now if you do partial fractions, who are they? A over x minus 3 and b over x minus 2. And then we lucked out, right? We hit the gold mine, or the lottery with crazy school this year because we are only doing the easy partial fraction problems, right? Like we can do that with the shortcut. So what would a be? If you guys calculate a, what would that be? I have to do it in my head real fast. I heard someone say 8. Did anybody else? So let's check. So 3 makes that 0. 2 times 3 is 6 plus 2 is 8. And 3, yep, 8 over 1. And what's b? So 2 makes that 0. So 2 times 2 is 4 plus 2 is 6 over 2 minus 3, negative 1. So negative 6. Right? And then that ends up being easy, right? So we would just say, oh, I'm going to anti-differentiate both of these guys. And that's 8 natural log of x minus 3 minus 6 natural log of x minus 2. And what's the big thing that we talked about that some of it bit you on the quiz? Like when we are doing these easy partial fraction problems, what's the thing that you got to watch for that's going to bite you? Like you got to make sure that both of these, when you anti-differentiate them, there's not a u sub involved. Like, so there wouldn't be like a negative floating out there. And that happened to a couple of us on the quiz. Not very many of us, but a couple. What are we left with? What haven't we talked about? Trig subs. How do you recognize a trig sub? I mean, Ellie just told you a second ago. What do you mean the equation?
Can't square x plus 1 equals 2.
Yeah, if you have one of those three forms, x squared minus a squared minus x squared, or a squared plus x squared. You have one of those three forms, that's a trig sub. Okay, so when your test, you're going to have two trig sub problems. You're going to have two partial fraction problems. You're going to have two integration by parts problems. And you're going to have two u sub problems. And then one additional one. Because didn't I say it was going to be 8 out of 9? Yeah, so you have to know all four. You can't avoid it. You know what I mean? But then you get that bonus one. And I can't remember what, I'm not going to tell you which one is the extra. Well, one I don't remember. But I wouldn't tell you. Other questions? I mean, I'll be honest with you guys. Like, I've told you this before. And maybe I'm only saying this because I'm sort of sitting in here too, but like, I'm pretty impressed with your guys's, in general, I'm pretty impressed with your guys's, like, getting through first semester and being where you are right now in this class. Like, if you would have said to me back in, well, let's not say September because that's too early, like early October, I would not have guessed that you guys would be where you are right now with your like level and depth of knowledge of this content. Like, and I mean, and that was a lot on you guys. I mean, because you guys did what you had to do. I mean, I think some of you are freaking out because you have a test on Monday, and this is like your first real test in probably almost a year. Like, I mean, in all honesty. And so, I mean, it's your freak out is somewhat understandable. Like, I mean, I'm not saying I probably wouldn't be freaking out too, but I think realistically, I don't know that the freak out is. I think you're in good shape if you've been doing what you've been supposed to do, what you have been doing all along and keeping up. You're going to be fine. It's not. And I probably sold it a little bit as, oh, this is a really hard test. And it traditionally is the hardest one, but I think if you guys have been doing what you're supposed to be doing, you're going to find this easier. What other questions?
Can you do a trig sub?
What do you mean?
Just for fun.
Find me one.
Maybe one similar to the one on the test.
Oh, you mean, let me take your test for you. Then it's not mine, it's your test. Like, well, Megan, what has to happen in order for it to be a trig sub? Because if we're going back to what Colin said a minute ago, what started our whole conversation, like, I don't know what to do. Like, when I see that, I'm not sure which one to do. If I knew what to do, right, like which kind it was, then I'm fine. So let's figure, like, so now that we know that that's an issue, like, think about Well, what has to happen, or what do I need to see in order for it to be a trig sum? But what's the form have to be in? So like we got three forms. We've got a squared plus x squared minus a squared, and then what's the other one? A squared minus x squared, right? So let's pick one of those. Let's pick like a squared minus x squared. And then there's also, I mean, I guess it's implied here there's a radical most of the time, right? I mean, we didn't say that, but so if I do, how about radical, make something up for me. Like, let's do one of these. Yeah. Okay, that'll work. So what's the trig sum? So here's the thing, like, it is sine. That, like, so that moment right there that Megan just had, oh, I don't remember that. We got it, like, knowing that going in is going to be far more, you're going to be in a much better place if you have that going into the test. Like, you don't want to, like, sit down and take a test and have to think through, like, all of that, right? I mean, you want to know that because you're just going to be spending a lot of time unnecessary, okay? So I heard someone say sine, that's right. So x is 2 sine theta. So then what's dx? 2 cosine theta. So this is 4 minus 4 sine squared theta. Oh, yeah, I forgot to stick that in there. Thank you. I would have caught that as soon as we started the next step. So next we're going to factor out the 4. This always happens. So what are we left with here? 4. I'm going to take that 2 and that 4, and then that's going to be square root of 1 minus sine squared times cosine.
Would it be 2?
Yeah, the 4 would be.
Yeah, but I multiply it with that 4 there. So that's going to be 4 cosine squared. Right? And so now we're at a crossroads, or we're at a place where you can either work this out or you know the antiderivative of cosine squared. And I'm telling you, if you know the antiderivatives of sine squared and cosine squared, your life is going to be a lot easier. Because now, if we're here and I know that antiderivative of cosine squared, boom, it goes right in. Right? It's 4 times 1/2 theta minus or plus sine theta cosine theta. And then what do we got to do? Draw the triangle. So x, what are the sides? What's sine theta? It's x over 2, right? And then one of those legs is the radical. It happens every time. Crazy how that works out. We designed it that way. I mean, that's why we made the substitution the way what we did. Okay, so I guess can I call this a 2? So that's theta, which is going to be inverse sine of x over 2 plus sine theta, which is beep, 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 x over 2 times cosine theta. Plus chips. So like that probably really wasn't that hard, but you got to know a lot. But I don't think the algebra was like unbearable there, right? Wasn't horrendous.
Is there one of them that we don't plus chips for? One of the,
Well, if it's a definite integral, you wouldn't use chips.
right, but for the four that we are doing, like, there's always chips.
Yeah, there's chips in any time you do an antiderivative. Yeah.
Are we gonna have any defined bounds in the test?
Yes. You will have, there's at least one definite integral. And proper integrals are definite too. But there is at least one. I haven't decided how many of those I was going to do, but I know there's at least one going to be where you actually have to evaluate it. And that's not, I mean, that's not a huge deal. It's just another step. Because I got to make sure that you still know how the fundamental theorem of calculus works. I mean, it is kind of a big deal, right? It is called the fundamental theorem. Probably should make sure we know that still. Man, time just flies when you're having fun. Yeah, Maddie.
Are we in proper, type 1 and 2, are we gonna be able to use
The P rule? Absolutely. Yeah, you can absolutely P all over it.
So does that mean like, well, we have a problem that's just like, you say whether it's like convergent or divergent and you don't have to put like a number for convergent?
That's how I'll phrase it. But you have to be able to justify your answer. So if it's a P rule, like you can just quote the P rule. But remember, the P rule only works for type 1s where it's 1 over x to a power. The P rule doesn't work for type 2s. So you can't quote the P rule if it's a type 2. You'd actually have to work it out.
type 2, there's no like infinity or negative?
Type 2 is when you have like the asymptote, you're integrating towards the asymptote. So like a type 2 would be like this. Right? No more questions? Well, don't hesitate to reach out over the weekend if you need to have a question about something. Many of you don't, which is totally fine.
Is there anything you think we should study now, like go over right now?
I mean, right now, well, we only have about a minute.
Oh, never mind.
I mean, I would definitely know sine squared and cosine squared. You're gonna need those. Yeah.
We need to know like what a double angle is.
You need to know the double angle identities. Not really. I mean, like, like this right here came from that. So if you don't know this, then you better know that in order to get this. You know what I mean? But I mean, there's not going to be a fill in the blank where it's sine of 2x equals, and you fill in the blank. I mean, like, I think you could do most of this without having them in your pocket, or I should say all of this. Yeah.
You know, like the derivatives of inverse equation.
We already. I mean, like, for example.
I mean, I would say so because sometimes that having those make things easier. Like for example, if I gave you this problem right here, Abdel, if you know the derivatives of inverse tangent, that is a simple problem. You have to do no work for it. You know what I mean? Because the answer to that right there is inverse tangent of x. You don't have to do the trig stuff. You follow me? What? You could do the trig stuff. Right. So, do you need to know those derivatives? I mean, not for that. Now, if I gave you this,
That's not on the test, right?
then you would have to know it because you would do that by parts, right?
Yeah.
Well, have a great time and a nice day. See you later. I'll see you probably ninth period when you come back. See ya. Kelly, thanks for that nice note. Yeah, that's what you said. He walked around and gave those. Yeah. See you later. Jimmy Sharp. Oh wait, you got to stand on it. Yeah, Mia, thanks for the note.
Oh, yeah, you're welcome. Ellie and I were laughing because we sit right next to each other in that class.
Well, and the funny thing is, like, you guys wrote very similar things, which I thought was kind of funny. Like,
I didn't read hers.
well, yeah, I'm not saying that you did. I just thought it was, like, it actually was, the fact that you both said what you said and the same thing, like, was, like, even more of a compliment to me. Like, that was what, I mean, I felt like, I was like, oh. But, yeah. I don't know.
squared minus x squared. And then so it's a sine theta. Otherwise, we usually use that 1 minus sine squared.
Nothing, it's just fun to look at. I did the same thing when I was growing up. Cherry. Cool.
You see the tower. You see the power of the stop. Did you see the tower? I thought it was 5 chocolate books at lunch yesterday.
You have DD one?
You?
Yeah.
Yeah, I'm glad we got that covered.
I know. You need to. I want to know.
I know, and Alice wanted to have it outside, and I was like, that's dumb.
Oh, it? No. Yeah. That, I think it'd be better than being in traffic over 1 minute.
Others going for
I don't know, what unit are you in?
Central.
Yeah, everyone's in the Northeast. I literally, I'll be with my boyfriend.
Yeah, I don't know people that are in these.
I know.
Actually.
Well, actually, Taylor and
Yeah.
but like, being out in Korea or Central.
So,
So, all 3 next year.
have you started the test room?
I did a couple in environment.
I was gonna start it last week.
I don't know. I think that's all we're doing. I don't know. So.
Hi, Billy. How you doing? That's good, huh?
Well, I feel like we would be able to. I feel like we should be able to. Because how many people can come? Because of the numbers.
I don't see like.
I don't care, especially for students. Yeah, I don't care if it's children. I mean,
I would like this really. I feel like that.
at least that's 4. I think we have that one.
I know.
If they don't.
Yeah,
We're not in the school. Even if I people watch it, yeah, that's gonna be good. I mean, it's just like a game, like.
What was that Macarena video?
That was our, like,
Just for fun?
no, Miss Britton wanted everybody to do that this morning. You did it in your advisory, then you got entered into some donut contest. So my advisor was like, oh yeah, we want donuts. So we,
I posted a video on YouTube of his class doing the Macarena.
but that was the only, I mean, it was the easiest way for me to, like,
Yeah.
record it, and get it to you. Yeah. So we have a test on Monday.
Yeah.
Yeah. How are we feeling about that?
Pretty good. All right.
We're feeling all right.
That's wrong with that.
It's wrong?
Yeah, square root of 4 is a 4.
You're right, but the square root of 4 times 2.
Oh, I
It's
didn't
4.
see that. It was covered by camera.
Burn roast.
Burn.
Yup.
Boom roasted.
Boom
Michael's corner.
Yeah, it's, well, the funny thing is when we were working this out last period, that problem someone asked, Miss Britton was actually sitting where you're sitting, and somebody was like, you did that wrong. And I was like, no, they pointed out that the square, it should have been a 2. It's like, nope, 2 times 2 is 4.
Yeah, I just can't see the 2.
All right, anybody notice anything different about the room? I put the lights in.
Oh, yeah. I mean,
During right before school started, I went and got the ladder. So,
changes the feel of the room.
the feng shui, the ambiance.
I think feng shui only takes me furniture.
Oh yeah, that's right. This has just changed the
The
ambiance a little bit.
Yeah, we should change.
We change the seat for him?
What do you mean? How do you want to change them? Well, back in the day, I mean, I've had this room arranged so many different ways. At one time, before smartboards, I actually had this room where the desks were facing some on this side and some on this side. They were facing a middle path, and I used both boards.
That would be so cool.
Yeah, but once the smartboard came along, like I actually used to have a smart board. It was right here. There was a smart board. Yeah, there was actually a smart board, not a project. Like that's a smart projector. The smart board was right here, and that was where the stuff was for it and hung down. That I got that in like 2006, and then I had that for a while, and then this new technology of these projectors came out. And me and Mr. McManus were like the first people to get that projector, the smart projector that you didn't need the board anymore, you just needed the projector. And I got that like in 2012. And yeah. Do I use the? Sometimes I don't really use it for the interactivity like it was designed for. I just use it to project what's on my computer. Like for one, it's getting old and you can't. If I use Smart Notebook, like, and if I do notes in Smart Notebook, like it's faded because the projector's so old. And then with Kids Online, it's doesn't work. Now, what I could have done with Kids Online was use that projector and then wrote everything in Smart Notebook, and then they would just see it. But they would never see me. They just hear me, and then but the pen is not great. The projector's responsivity is not great anymore. It's just old. So.
Do you always use whiteboards? Do you use chalkboard?
What?
Have you always used whiteboards? Do you use chalkboard?
The chalkboard, like old school chalk? Yeah, I mean, I used to use. I mean, there's probably stuff written on this chalkboard behind these whiteboards. Because when the smartboard was put in, the smartboard was actually put in before these whiteboards were. That's why the whiteboards only go up; they don't go all the way across. And back there, those whiteboards are on top of chalkboards. Chalkboards that I really, really like. Like they're real, the chalkboards back there are really nice chalkboards.
Yeah, why'd you cover them?
Because whiteboards are,
Oh,
they're nicer. But back in the day, I mean, I would like leave school just covered from like here down.
There's
chalk.
a chalk, they got rid of it in like the 80s, but they brought it back to like the new company bought the.
Yeah, it's like this Japanese chalk. It's
Yeah,
really good.
Yeah,
it
she
does.
talked about that.
Yeah.
last
It
year.
really tastes like that though. That kind of stuff.
We talked about that last year.
It's interesting, I am in this room because I was really a chalkboard snob. Like my first room when I came to Fairmont in 1998 was where Brewer is. That was my room. And the chalkboard that was in there was a piece of junk. Like it didn't erase nicely, like it just left all kinds of dust everywhere. And it was really small. Like it was only like, there was one chalkboard that was like 8 feet long. And this is before smartboards or anything. And I was like, I'm not teaching, if I had the option to get out of there, I did. I was saving it because it was terrible. You had this tiny little space to write on. So when I heard this room was available, I was like, I'm moving over there. And so I came here the next year. Now, ironically, had I known 4 or 5 years later, smartboard would have become the thing. And then I could have got whiteboards installed on that. I would have stayed down because that's a great room.
Yeah, she has whiteboards in there now.
Yeah. Yeah, none of that was there when I was in there. It's just an old school chalkboard. Terrible. Piece of junk. Piece of junk. But that chalkboard back there, so nice.
Isn't there like always been dust that doesn't give off, chocolate doesn't give off dust?
But even the chalk that gave off dust, that chalkboard was really, that one that's back there is really smooth. So when you wrote on it, it was just really nice to write on. And also, it erased really nice. Like when you erased it, it was like brand new. It looked like a clean slate, literally. I mean, that's where that expression came from. Yeah.
When did you start doing like the college
Like,
Like what?
well, I mean, but where it really became a thing, like the first pennant I ever got was this one. Because Kate Jackson graduated in 2000. I had her in pre-calculus honors, and then I had her she was in the first class of BC, like BC Calc. That didn't exist until first 99-2000 school year. That was the first year we had it. And we had one class of it, and she was in that class. And when she said she was going to go to Harvard, I was like, oh, get me a pen and I'll hang that in my room. I thought that was really cool. I had to going to Harvard. And so she got me that, and then I got a couple others here and there. And there was a bulletin board on that wall over there that covered the entire wall. And so I was putting them on that, and then the bulletin board fell down. Like it came unglued or something. You see like where that white is on the wall? I think that's where the glue was. It fell off the wall. So then I put the pennants up there, and that's when I started putting the names. And then it just took off from there. It's nice, easy decoration. I don't have to put posters up. Those silly, inspiring posters, and cats.
I like how you have the.
Well, that's just because we ran out of room up here. Heck, why not? Let's finish it off, It's 11. It is on.
Yeah, you need more. Anyone else?
Anybody want a little hit? So yeah, I kind of miss chocolate.
She go there.
We can take notes on like that little piece.
That would not.
Well, this board's not a great board. fact, this is the kind of board that is actually in Brewer's room. Is this kind of board. Because it's not, it's kind of like it's rough. I hate that. The ones back there are smooth, and they just erase. Like, you know, I could write on. Is there any chalkboard here? I mean, this doesn't erase.
Yeah, I have chalkboard paint in my room, and it's so freaking hard to erase.
Yeah, like you really need to wet that to get it to erase. But that one back there.
That's what I do.
You can just take away from it. You can be a class project.
Yeah, let's do it.
I mean, I had that thing down in 5 minutes if I went home and got a drill. But
It's quite a handy.
I mean, it's. But I don't want to take it down. Like, I don't want to use that chalkboard.
Well, it does that.
Yeah.
You should.
We'll take those. Well, those.
Yeah, take those
We'll
out
take
and
it
down
for you.
yes.
Those need some work.
And then we can flip the desk. It'll be like a whole new room.
Those boards up there need some serious work. Like they need to be cleaned and then they need a treatment of WD-40.
I like those.
Like,
Oh, wait, look.
Chicken
Wait,
nuggets.
no one's in here for that.
Are chicken nuggets the same as strips?
I voted no. Did you vote?
they're totally.
Thank you.
They're literally not even, like, chicken nuggets are made by, like, pureeing chicken and then forming it into a shape. Tenders are made by, like, having cuts of chicken fried. They're
Right.
not the same thing.
Well, not all chicken nuggets are that. Chick-fil-A nuggets aren't that.
Most chicken nuggets are
Chicken
that way.
nuggets.
Chick-fil-A nuggets are just, they take chicken tenders and cut them up into like little bits.
And they're so better than.
Everyone needs to vote on that.
Oh, it's better
Kevin, I don't think everybody needs to vote.
than. We should vote on
Pretty
that
clear.
tomorrow.
Thank you.
Like you put yes.
That's my daughter Kate's 100 days project from first grade.
You got a something?
100 ways to make
Disappointed.
100.
99 plus 1 is on there twice.
What did you do for your?
99 plus 1's not on there.
Well, it's 1 plus 99.
But those are two different ways to make 100. And you can't tell me the commutative property. This is actually kind of you know, we could have a serious conversation about this.
All right.
Is 1 plus 99, is making 100 the same 1 plus 99 as 99 plus 1?
Yes.
1 plus 99,
I want to say yes, but I feel like if I do, he's going to yell at me.
well, 1 plus 99 and 99 plus 1 are both equivalent, right? But is it making 100 the same way? And no, because if you put a context in here, you can immediately have that. Would you rather have $1 and he give you 99, or would you rather have $99 and he give you 1? That's not the same situation. Yes, the end result is the same, right? Think about that.
Yeah.
I mean, it's like 2 times 3 and 3 times 2. Those are equivalent, but they're not the same. One is 2 groups of 3, the other is 3 groups of 2. It's just they're equivalent. That's what, you know, kind of a big ideas in elementary now. So talk about that. Like, so that's why that was a legit thing. I mean, like 2 plus 98's on there.
What's that thing above it? That black with all like the
That's a slide rule.
Yeah, it's a giant slide rule.
You know what a slide rule is?
No.
I've heard of it, but I
It's a
think I actually.
calculator.
A slide rule is a calculator, like what they use to do calculations. Like you can multiply like on that.
You can do a lot of stuff. You can do squares.
Yeah. I mean, there's
Sines, cosines, tangents.
depending on how many rows are on it. It's basically there's a lot of numbers that are printed on there, and then it actually works off of the idea of logarithms. But you know, you can multiply like 27 times 32.
Isn't it 2.7 to 3.2?
Right. The way everything you do on the slide rule is in scientific notation, though. So, like, you would really be multiplying 2.7 times 3.2. So you'd move 1. The thing on that is the cursor is missing on that, which is like this plastic piece that slides over all of the big part that has a line on it. So you'd move one piece over to 2.7, then you take the cursor and move it over to 3.2 on a different row, and then you line up those numbers, and they would give you a number like 6.8, and then you would know that the answer is 68. You had to know scientific notation, like the order of your answer. So if it was like 317 times 267, like you would have to know that was a 10 to the 2 times a 10 to the 2, which your answer is going to be a 10 to the 4. Like you would have to know that.
It's just even harder.
But it's harder for you because you have seen the other side. Like people who were doing that when they first got that, they thought what Desmos is to you was that thing was to them. I mean, they're like, oh my God, this makes it so much easier. Like, you know.
I really thought I didn't forget that today, though.
What?
I used to keep my slide rule in my backpack. I have one. I used to keep in my backpack. I didn't bring it today.
I have one of those hanging in my den.
Wait, I have one?
At my house, yeah. Well, I mean,
It's like your living room.
I don't have a man cave, but I have there's a room in our house that has a little couch and a little chair and a TV. It's a really small room, but in there there's one of those giant slide rules, and there's also a giant wooden compass on the wall.
Does the one in your den have the cursor?
It does, yeah. The one in my den that actually one of our neighbors down the street called and said, I found this in my attic. Do you want it? I said, yes.
Does it work?
Yeah, it has all the parts. Yeah, I mean, it legit works.
They don't like stop working.
Yeah,
I'm gonna bring one of those to a test. Set it on the desk. Have like a giant.
that slide rule is actually like it's what you would use to teach someone how to use a slide rule. It was like the smart board of its time. I mean, it's this giant thing. Everybody would have their own smaller ones, and so that was used for demonstration purposes. What? They're
Mine's like
yeah. I mean, the bigger they are, and the more space, marks on them, the more accurate they were. I mean, some of them they weren't super accurate because you couldn't, like, say you wanted to multiply 277 times 396, like that's 2.77. Like you had to add, what you probably ended up doing was doing 27 times 39, and then you just estimated the other place.
Isn't that what they used to do for these mechanical calculators?
What?
Didn't they, for a short period after they used mechanical calculators, didn't they? Like credit calculators?
Yeah, I mean, not for very long though, because the calculator, the electronic calculator, came out in like the early 70s.
Yeah, they only made
You have to like round on the thing.
What?
You have to like round on it. Like
Yeah.
it doesn't go as far.
Right. You have to. I mean, depending on how accurate the slide rule was going to dictate how your answer was rounded. Yeah. But if you put a person on the moon with one of those things, like, I mean,
like more than one.
I mean, the engineers back in the day, like that's what they were using to do their calculations. And we put a person on the moon, and the computers that they were using back then, like you have a more powerful computer in your pocket right now than what they were using when we put someone on the moon.
Isn't it like way more powerful?
Way more.
Like,
I mean, it's like
order of magnitude.
Yeah, hundreds of times more powerful.
I hear it all the time. People say it's more powerful than the computer they put this on the moon with. It's like, yeah, but it's like way more. Like kind of close.
And that computer that we're using back then would have been the size of this room. It would have had all kinds of tubes in it. I mean, I didn't know how they worked.
They used vacuum tubes for logic gates, and they would read off punch cards.
Yeah, I knew the punch cards.
Where the term bug comes from, sometimes you get bugs on a punch card.
Oh, really? Oh, I didn't know that.
They it's just me.
Does anybody have any like legitimate questions about math? I mean, we can sit here and talk about history and the development of the calculating machines. I mean,
It's fun. I like this.
and we do have a test on Monday. That's a big.
Yeah.
Billy and I
Figure out like what technique to use.
What technique to use is like the big thing. I mean, you sort of have to run through a checklist in your head, right? And you also have to have done enough problems that you have experience where you recognize, oh, this is a classic integration by parts problem, or this is a classic partial. Yeah.
The 101, the integral of 2x plus 1 times e to the x squared times e to the x dx.
Say that again.
The integral of 2x plus 1 e to the x squared times e to the x dx.
Like that?
Yes.
Oh. Samuel, you're gonna kick yourself when you see this. Because that's what happens when you multiply. So that's just. What's that?
You make it seem so simple.
Yeah.
I've done thousands of these.
Yeah.
You have to realize what's going on up there. It's not going on up here.
I mean, Kevin, I've done these so many times. As soon as I wrote this down, I knew this was what was going to be the answer. Because I knew, I've seen so many of these, I knew that 2x plus 1 was there. Like, I'm thinking like the person that designed the problem. Like, you know what I mean? Because they want, that 2x plus 1 was there because, I knew that was going to end up being the derivative of that. And that's only experience. I mean, it just comes with experience. Oh, jeez, forgive me. Firing.
Literally unusable.
I want to be like a college football coach that gets fired but yet still gets paid.
You just keep like you have a professor with a tenure. He can't fire you.
Well, I mean, that's kind of where I am now. I mean, I'd have to do something pretty egregious to get fired, but or be really bad for a period of a few years in a row. This Britain came in last period, and she came in. Every observation was like, "Oh, you're not doing any math. Like all you guys are sitting around talking about slide rules." Like if that happened every single time, and it happened for a period of years. But like college football coaches, they get fired and they keep getting paid. Right. Yeah, contract. Charlie Weiss. Anybody know who that is? Charlie Weiss was the head coach of Notre Dame. Like a couple coaches ago.
Yeah. No,
For a
because
while,
he was
I'm
fired.
disappointed.
For a while, Charlie Weiss was the highest paid employee at Notre Dame, and he didn't even work there. Because they gave him like a 10-year contract. It was like multiple millions of dollars, but then they started stinking and they got rid of him, but they had to keep paying him. So for like 3 or 4 years, he's like the highest paid employee at Notre Dame, and he wouldn't even work there.
So all you have to do to get rich is just become a coach of a team, get a long-term contract, and then just run it into the ground.
Right. But you gotta be pretty good at what you do.
Yeah, to get into that position.
So I don't know. I'm probably not gonna get fired though for getting that DX.
It was like a baseball player that instead of getting all of his money from a contract like after the season was over, he had it like paid like yearly or something, and he's like still getting paid. He's
And I mention basketball players all the time, because they're heels in like football.
That's not what I do. Most players go bankrupt after they.
Didn't one sports player get his payment in like Bitcoin or something like 3 or 4 years ago? I remember it was something like that.
That would be
I think
kind
Darren
of
Shan.
Yeah.
So your test is going to have, it's going to be 8 or 9 problems where you choose 8. Then it's going to have 2 improper intervals, 1 of each type. You can use the P rule. You're welcome to use the P rule. But remember, the P rule only applies on type 1s. Okay? P rule only applies on type 1s. We've got U subs, integration by parts, partial fractions, trig subs, right? There are 2 of each, and then a third one. Like there's one of them has like there's 3 in there because there's 9 problems. You choose 8. So you have to know how to do all 4 methods. Like you can't say, well, that's going to be the one I'll skip.
Wait, 9 total, and we get to pick 8.
You pick 8, but if you do all 9, you get bonus. I will tell you that knowing the antiderivative of sine squared and cosine squared, if you have that in your pocket, it's going to be helpful. Right? Because then you won't have to work it out. Last period we did, I mean, they asked me a few more questions. We're going to watch that video. We talked through some of your issue too, like how do I know what to do? But I mean, I will say in general, I mean, I'm pretty impressed, honestly, like where people are in this class, given the way we started. I mean, like if you had said to me in early October, like some of you would be doing as well as you're doing, I probably would have questioned it.
Where would we be right now if we didn't have no COVID thing?
I mean, like what would?
Like, I'm assuming we're behind, obviously.
We're not that far behind. We're like maybe 1 or 2 weeks far behind. But that's my point, is that like, yes, we're 1 or 2 weeks behind where we normally would be, but like I don't feel like that in general, people know this stuff at a lesser level. Like I think in general, people know it about the same level that they normally do. Like, which is a testament to you guys. I mean, that's, you know, because you're doing what you're supposed to be doing. Now, people who haven't done what they're supposed to be doing, like that's a totally different discussion. But you have those no matter what, COVID or not. You always have people who like think they can just come to this class or come to any class and just never do any homework, and then they end up saying, "Oh, why do I have a D?" You know, like, but those people are more the exception than the rule. But I think the people that like, you know, most people have a pretty good handle on things, like, which is amazing considering how this year started. I remember the very first class that we had that was online with you guys, like when that was over, like what I said, I might get fired. If someone heard me, if I said that to a class, like I was so frustrated with how that went, and like just did not go like it's supposed to. Even the first probably 3 classes, like this is terrible. Like I can't make this work. But somehow you guys figured it out. So.
I think part of the reason it seems like it works online than it actually is quite nervous on the Zoom calls. Like they may know what the answer is, but it's not safe because they're just don't unmute.
I think there's a lot of that. I mean, it's the engagement piece. People aren't, you know, because they're intimidated about talking on Zoom calls or whatever. But if you're intimidated about talking on Zoom calls, then like that makes you more disengaged, like into what's happening, and where you're just sitting there like watching the world go by, you know. And you have other distractions. Whereas in here, like when you're sitting in front of me, like you might not be disengaged, but there's not a lot of distraction. Like there's not other things that you could just go off and do and pretend that you're there, like you could first semester, when you have your camera off and you're just going and watching movies while class is going. And don't tell me none of you did that, because I'm guessing most of you did that at some point in time. My kids did. Like, but in here you can't do that. Like even if you're going to disengage, you're still like engaged just by the mere fact that you're sitting. But I don't know. Hopefully that was a one and done, right? That we don't ever do that.
I am glad we were here physically for the methods of solving integrals. I feel like that would have been hard to do.
Yeah, if we'd done this online, I'd be killing.
I don't think so.
Oh, I do.
I don't think you would.
I would definitely not be doing it.
Because first I would have made lots more videos, like that you would have watched, and you would have done what you needed to do to be successful. Like you did it when we did derivatives. You learned the chain rule, the quotient rule, the product rule. You learned all that stuff same way, right? Like, yes, that seems really easy to you now, but if you go back to September, like that was just as foreign and scary as this. Like, I mean, I think I don't think you would. I think you would have found a way. I mean, I would have made more videos. I would have like done that, like all these times where I was sitting at you guys asked questions, like, well, those times wouldn't have existed, but I would have just made the videos answering the questions that you didn't ask, that I knew you had. Which I guess that begs the question, why don't you do that anyway? Why don't I do that now?
This class used to be so big. On Zoom.
I tried writing.
This class was big.
At least on Zoom.
Yeah, I'm
Uh,
doing it.
We only lost like 3 people.
That's why I remember telling. Because there's so many.
I feel like 3 people would fill out the class full a lot more.
Yeah.
3 people make this feel like more people, bigger, much bigger. Yeah, I agree. It's that whole row.
Yeah, this row would be.
Who did we lose? We lost AJ.
Will.
Who? Will?
Yeah.
Who? AJ
AJ,
and Will. Noah. We lost Anna.
Oh yeah, Anna changed.
Anna's in the other class now, though. Lydia. Oh, that's right. Lydia was in. I keep forgetting Lydia was in here. All right. Well, I guess it's time to go. Oh, Adrian was in here. I could. Adrian could walk in here right now, and I would know. I have no idea who that is.
I don't think I've ever talked to him.
I did from there.
Well, reach out if you have questions when you're studying.
You joined the
Oh,
Discord.
you will. I'm gonna smoke some pulled pork tomorrow.
So excited.
You too.
Why is your big open?
I know. I had a weird lunch today.
What is it?
Vegetarian option is hummus.
What?
It's hummus and pita bread. And I mean,
Peter was probably 5 years old.
you won't be able to tell.
Exactly.
Ready for your calculus test?
I will be.
Yo.
Yo, yo, yo. Yo, yo, yo.
You never said I am going to go for completion. It's kind of one of the saddest things that's ever happened.
Oh my god.
What?
I think it expired in 2014. I didn't even know these things could expire. You can tell too.
This is a good question. Did it? Because like I can't tell.
It's like random letter number. It looks like.
It says 20H14GO4 22 532. I don't know what these numbers mean.
Fire.
32 a.m. Expired this morning.
Where's the Delaware?
Over by grade.
It was in Illinois. If you go down Wilmington to Patterson, and take Patterson for a while, there's this like doggy daycare, and you turn over, you take a left then right before the doggy daycare. And then you can see just.
Alright, I'm gonna get you guys first then.
Yeah, I can direct you.
Are we even going tomorrow?
There is